Hi guys, today we are going to discuss about the basic assembler functions. So this is the one of the topic from the SSCD, that means System Software and Compiler Design. Let us see that what is meant by basic assembler functions. In this, assembler means it is a software which converts low level code into machine code. That means low level code means it is understood by humans and machine level code means it is understood by computers. So the functions which we are going to do here are just converting the low level code into the machine level code. So that means here there are only three steps guys. These are very simple. If you learn with interest then it will be so easy to learn. So we need to remember all these three steps. Let us see that what is the program they given and how to solve that program, that means a low level code into machine code. First of all, I will show the program, how the program will be. See guys, this is the program. This program starts from here and it will end at last. It is a lengthy program guys. I just took it for easy purpose. If you know it from the lengthy program, then it will be easy for you to solve the small programs. Let us see here in this lengthy program. That means here I am going to say about the columns, how many number of columns are there and what are the names of the columns. Let us see guys. This is the location of the instruction. Then this is the source statement. Source statement is of in the three columns. That means it has three columns. The first column is name of the instructions in the memory. That means these are the names of the instructions. That means what we need to perform. Name of the locations in the memory. That means names of the locations in the memory. Then the second column is the assembly directives or mono mnemonics. Mnemonics are assembly directives. And this third column is the address of the location. So this is the name of the location in the memory and the mnemonics are assembly directives and this column is the address of the location. This is the object code guys. Whenever they give the program, they will just mention these four columns. Let us see how to change this low level code into the machine level code. Let us see through the three steps. That means the first step is assign addresses all the lines in the source code. So we need to assign the address of the all lines. That means in here there are so many lines. We need to assign these addresses in the source code. See how to assign these lines means guys. Addresses are assigned in hexadecimal form. That means what is meant by hexadecimal form? Hexadecimal form means from 0 to 9 we will just represent the numerical values. That means 1 to 3. After 9 in a decimal form we are going to represent the 10, but here we are going to represent it as A, B, C up to F. After that we are changing the position. That means here if we start with the 0 0, that means if you keep 0 0 0 1 like this up to here 0A 0B 0C and up to 0F, then we are changing this 0 value into 1. That means 1 1 like that, 1 2 1 3 and so on. Here also up to 1 8 like this. After all this, just again we are going to changing it into ABC and then like this we are going to write it in the hexadecimal form. That means let us see here guys. Here the location is 1000 and after that here why we written the 1003 means guys, here there is a word, one word. Word means if we take this 1000 as one word, then it the one word is equals to 3 bytes. 3 bytes guys. One word is equals to 3 bytes. That means how to represent this guys? 3 bytes means 1000, 1001, 1002. After this are these 3 bytes are stored under the one word. These 3 bytes are stored under the one word. Then for this location, after placing like this, if you if you take like this, if here it is 1000, then the next place is 1001 and then 1002. After that, we are going to take it as 1003, 1004, 1005, like this. So here this 3 bits combination is called as a one word. 3 bytes. 3 bytes combination is called one word. So we are representing the first address, that is 1000 here. After all that, after completion of 1002, again we are starting from 1003. So 1003 to 1005 up to here. 3, 4, 5. So this is also one word. So what is the starting address of this? Here 1003. So 1003 is the starting address. I am just replacing it here. Like this, after 3 bits, 3 bytes, we are going to represent the location. In the same way, we are using this. That means in hexadecimal form, we are writing that. So after see that second point, guys, the second step is, so already they gave the locations in the question, so there is no need to write the locations again. It is very easy. If they gave the question, we just representing the first step. After that, generate object code for all the instructions. That means they gave the object code, guys. See, they already gave the object code. If they won't give any object code, then we need to that means we need to write the object code. Let us see how to write the object code, guys. Here, to write the object code by ourselves, we need to know some instructions. What are the instructions we need to use for this means? So in this table, they just mentions the mnemonic name and the opcode number. So if we select any mnemonic name, that means if we select the LDL and the opcode is opcode number is B. B means what, guys? B means 11. Already you know that here it will use the hexadecimal forms, and in the hexadecimal forms A is equals to 10 and B is equals to 11. So here we are going to use the LDL. So here I am using the B as opcode. That means they only give the B. Let us see how to represent it. See, guys, this is the table. Whatever I told you, that means this is the program. Here I just selected the LDL, and this is the assembly directive, and it is the address of the location. It means I just took the LDL and RETEDR. So here let us see that I just took it. If you want, you can select anything and just see the table. That means mnemonic code, that means mnemonic name and opcode. Let us write this LDL opcode for, and this is the address for this location. See, guys, these are the things we just got selected. That means this is the assembly directive and it is address of the location. Let us see the opcode for this LDL means opcode is B. If you want, you can put any 0 here. So after that, what is the address for the location? That means RETADER means for this, what is the address of the location? Let us see how to check this, guys. Here already they gave that this is the address of the location. Now we are going to check for the name of the location in the memory. That means this is the just, it is the address, guys, address of the location. So let us check for the name. That means in which column we need to check? This is the first column. In the first column we need to check this is the name of the locations. Let us see wherever the RETADR is present. So this is the RETADR. This is just erasure. See, RETADR. Let us check for in at any places it will be presented. Here in this in this column only we just have the only one RETADR. So what is the address for it? That means what is the location for this means 1033. Just write this here. That means the first step is in the, that means in the whole, in the second step, we just need to select any of the assembly directive and address of the location. This is the assembly directive column and this is the address of the location. You can select any of these. So I just selected the LDL and this is the address of the location. So after writing them in the our answer sheet, after writing here, let us check for the opcode for this LDL. The opcode is B. So let us check the location, that means the name of the location. This is the location, already this is the location. So check the name of this location in the memory, whether we have it in the memory. This is the location of the memory. So here we just got, this is the location address. Just write it here. That means 1033. This is the name of the location in the memory. So here just write the binary codes for this. This is the 0. So why we need to represent this 0 means, guys, here in the object code we need to get the 8 bits. That means in the first bit we need to store the 8-bit value. In the first byte we need to store the 8-bit. That means here if it is like this, this is like if it is 1000, sorry, this is the address, no, 1033. So after that 1034, 1035. Here for each byte, these 3 bytes are called one word. That means word. In this each byte we need to store the 8 bits. So for that purpose here, if we won't replace it with 0, then we just got the 4 bits. So for our convenience, we just added the 0 in front of it. So just write the binary code for B also, 1011. Just write the binary code for this location also, that is 0001 0000. After that for 3 also we need to write that 0011 0011. Just locate these bits, these all bits as 8 bits in one byte and 8 bits in second byte and 8 bits in third byte. So these 8 bits in one byte, these 8 bits in second byte, and these are in third byte. This is just representing the opcode, guys. Just we need to select any of the, that means any of the location, and that means it is a name, assembly directive, that means name of the assembly directive, and this is the name of the location. So after selecting it, we need to check whether if it is present in the location of the memory address. If it is present, just write the location of it. Just represent the location here. After for that location, we are writing the binary code. We are replacing this binary code in this format. After all that, there is a third step, that means the last most step. The third step is we need to generate the object program. That means we need to generate the object program. So while generating the object program, we have 3 methods, guys. We have 3 methods. One is a header record. Header record. Second one is a text record. Text record. Third one is end record. So these are the 3 steps. Here also we need to perform these 3 steps to get the final answer. Let us check for the first thing, that is a header record. Let us see. I am just showing the things how to write the steps for this header record. This is the header record, guys. These are the steps. In header record, we have 19 columns are present. Here 19 columns are present. 19 columns are present, and the first column is represented with H. That means the first column is represented with H, and 2 to 7 columns are represented with the program name. Whatever the program, we are representing the program name. And 8 to 13 we are represent the starting address of the object code. Starting address, it should be in the hexadecimal form. Then 14 to 19 column is represented with the length of object program in bytes. See, by solving the problem, that means by changing the low level code into machine level code, we just understand these steps. Let us see it with an example. See, guys, in header record we are having the 19 columns, I just represented them with the numbers. Let us see, the first column is represented with H. So just cut it for up to 1. So after H, what we need to write, guys? In the second column, we need to write the name of the program. That means it consists of 2 to 7 columns. It is a second column. So here we need to write the name of the program. So what is the name of the program, guys? See here, name of the program is in the assembly directives line. That means in the first column, whatever they gave at the top, that is they gave the copy at the top. So this is the name of the program. For every program in the assembly directives line, whatever they gave as a program, that is the name of the program. So just write the copy here, COPY. So after that, these two lines are, that means these two columns are empty, just leave them. Now we are going to write the next 8 to 13 columns as a starting address of the object code. See guys, what is the starting address? See, again see, this is the location, and what is the starting address, guys? 1000 is the starting address. So here what we have, the nearly 6 columns we need to fill these all 6 columns. How to fill? We just have the starting address as 1000, so I am writing it as 0010000. I am just adding the zeros in front of the 1, so I am just cutting it up to here. After that, again I have 14 to 19 columns. So here we need to write the length of the program. How to find the length of the object program, guys? So here we have the formula, that is end object, that means end object address minus starting address plus 1. Let us see here, what is the end object address, guys? At last in the location column we just have 2079 as the end address. See here, so 2079 is the end address, that is I just wrote here. Then what is the starting address? 1000 is the starting address. Just write it here and just subtract it. What we will get, guys? 1079. Now add a 1 for it. So here what we will get, 107, not 10, guys. In place of 10 we need to write it as A. So 107A. This is our length of the object program. Just write it here, guys. These steps we need to write here. So for this also, it consists of only 4 bytes. We need to write it in the 6 bytes. See, 00107A. This is the header record, guys. Header record is only one code. Only one code. And end record is also only one code, because header record means, guys, there is only one starting point and there is only one ending point, and there is only one and only starting address. After that there is only one name of the program. So in end also there is only one ending address. After all that, in text record we may have nearly more than one code, guys. We can get 2 or 3 codes in text record. So I think you all understood how to write the header record. So it is that means very easy and important to remember the columns names. That means here, see guys, column 1 is to represent the value H, that means a letter H. Why? Because by seeing the H we will say that it is a header record. For column 2 to 7, program name. What is our program name, guys? Copy. I just wrote it here. After that, 8 to 13, starting address of the object code. 1000 is the starting address, guys. I just represented here. These 2 zeros are to complete that means to fill this column. After that, last step is 14 to 19 is length of object program. So what is the length means? How to find out, guys? End address minus starting address. So whatever answer we got for that, adding plus 1. So whatever the answer we got, just writing it here. That's it, guys. I think you all understood my video. So in my next video I am going to tell about the how to write the text record, because text record is somewhat typical and it is something hard to understand. So thank you for watching my video.